supercontinente mais antigo do mundo. O supercontinente mais antigo do mundo é o Valbará. O Valbará existiu há cerca de 3,1 bilhões de anos. Curiosidade: o supercontinente Valbará começou a formar-se há 3.600 milhões de anos e ficou pronto há 3.100 milhões de anos e começou a separar-se há 10.800 milhões de anos e acabou por se extinguir, mas ainda existiam outros supercontinentes. O primeiro supercontinente foi a Casamante, e existiu há cerca de 2,7 milhões de anos. O segundo supercontinente foi a Luna, e existiu entre 1,8 e 1,5 milhões de anos. O terceiro foi a Rodinha, que existiu há 1.000 milhões de anos. O quarto foi a Patónia, que existiu há 600 milhões de anos. E o último foi a Pangeia, que existiu há 300 milhões de anos atrás. Esta aqui é uma imagem da Cernolândia, da Nuna, da Rodinha, da Panótia e da Pangeia. O supercontinente Valbará era assim. Isto é uma imagem de como os cientistas pensam que era o supercontinente. A rocha mais antiga do mundo tem 4,4 milhões de anos. A rocha é um fragmento de zircão e foi encontrada em um rancho na Austrália por pesquisadores da Universidade de Wisconsin, com uma diferença de 0,1 milhões de anos da data de criação da Terra. Agora vamos vos mostrar um vídeo sobre Valbará.
The Earth, 3.4 billion years ago, and plate tectonics pushes the proto-continents together. They combine to form ever larger tracts of land. Scientists suggest that cratons combine with other cratons to form a supercontinent, a huge continuous stretch of land. It's called Valbarra. Scientists are unsure of its exact shape or size, as only a few pieces, like the craton in South Africa, still remain. But Valbarra's days are numbered. A rising plume of heat is growing beneath it. It's about to rip the world's first supercontinent into pieces. $2.7 billion years ago, Valbarra, the world's first supercontinent, still dominates the planet. But plate tectonics, powered by heat from the Earth's core, is about to split it apart. Rock is a good insulator. When a continent gets very large, the rock traps heat beneath it. As it gets hotter and hotter, a plume of superheated magma builds up beneath the giant continental mass. The temperature continues to rise, and pressure in the mantle increases. Eventually, the crust can no longer contain the pressure, and the hot lava breaks through, ripping the land apart. You can see this process happening today in Africa. Heat from the Earth's core is ripping the continent apart. A giant rift valley runs from the Red Sea down to Mozambique. Giant cracks are opening up in the land. Volcanoes, like Kilimanjaro, mark spots where molten rock have risen to the surface in the past. In 10 million years, the eastern half of the continent will have split away. The molten lava trapped beneath the giant supercontinent of Valbarra eventually smashes through the surface rock. The continent ruptures into several smaller pieces. These bits of land sail across the Earth. But nobody knows what happens to them or what the planet looks like at this time. The Earth is entering the Dark Ages. It is over 2.5 billion years since it was formed. It will be over 1 billion years before another supercontinent forms. The Earth. is entering a deadly cycle of destruction and rebirth.
The theory of continental drift suggests that we go through cyclic phases of continental dispersion and then continental collision. And the continents then seem to move apart from one another and then collide with one another over a maybe 100 million year or more time scale.
When a large continent splits apart, the separate pieces travel away from each other, pushed by the creation of new land at the ridge between plates. Because the Earth has a constant surface area, the same amount of land created must be absorbed into the Earth. This process happens at subduction zones at the junctions of plates. At a subduction zone, crust dives down into the mantle to be melted to form new rock. When the plate subducts into the Earth, it brings two pieces of land together. When they collide, a new supercontinent starts to form. It is now 1.1 billion years ago on our timeline, and the next known supercontinent has formed. Its name is Rodinia, and it holds almost all of the continental rock on the surface of the Earth. Still, no one knows exactly what it looked like, but at its heart is an area that will eventually become North America. 350 million years later, the cycle of annihilation and creation starts again as the buildup of heat beneath the surface of the Earth tears Rodinia apart. When Rodinia splits, it forms several smaller continents that for millions of years drift apart and then drift back together again to form Gondwana, a supercontinent in the southern hemisphere. Eventually, after several hundred million years, Gondwana slowly splits apart. Plate tectonics pushed the land back together to create the world's last supercontinent. It's a huge landmass known as Pangaea. All the continents we know today are here, joined together.
As fontes que utilizadas foram Esperamos que tenham gostado. Trabalho realizado por Bárbara Carrilho, número 4, Liliana Vinho, número 14 e Rita França, número 21.